welcome to MTH 232 class. Today we'll be talking about Riccati differential equation, Bernoulli differential equation, and Claude's differential equation. So we'll quickly, let me share my screen so that we can continue from there. I've seen one of the questions here talking about Riccati. Is there in question? They didn't number it. I believe you can see my screen.
Yes, sir.
I saw it before you guys came in. Yeah, it's here. Solve the Riccati equation. dy dx equals to -1 minus x raised to power 2 plus y raised to power 2. Remember, I told you I will teach you how to read LaTeX. This is LaTeX. They use LaTeX to write it.
Okay.
But it did not load. It was not loaded. Please write the question down. dy dx equals to -1 minus x raised to power 2 plus x raised to power 2. So these are the options. If you have another past question, yes.
Can you read the question again? dy dx equals to -1.
-1. You can see -1 here. Then minus x raised to power, this is raised to power sign, okay, raised to power 2 plus y raised to power 2.
Okay.
Okay. Let's move on for today's class. We did something last week about cooling, but today I discovered that we've not discussed this. Bernoulli Riccati and Claude about differential equation. So let's look at the Bernoulli first. From there, we'll move on. Bernoulli differential equation. So under the Bernoulli differential equation, it's like it has the form of dy dx plus p of x y equals to f of x y raised to power n. Just a minute, please. Hello, are you guys there?
Yeah, yes, sir.
Okay, let's continue. So on the Riccati and the Bernoulli differential, now we're working on Bernoulli differential equation, is of this note. When you have a differential equation that have extra factor, this extra factor, so of this particular form, it's called Bernoulli differential equation. Now, we can call this one equation 1. So under the equation 1, we can you see my screen, please?
Yes, sir.
We will need to make some substitution here by using substitution. The key word here is let W equals to y raised to power 1 minus n. Y raised to power 1 minus n. Now, can we differentiate the W now? The W, the X is equals to, remember, when you are differentiating Y with respect to X, what happened? From the implicit function, you remember?
Yes.
You add the Y, the X to it. You remember that? So if I want to differentiate this one, you bring this one down, 1 minus n, y, 1 minus n minus 1. You remember? Then
yes,
the y, the x. Because we are taking this one in form of x, we are differentiating it, it's a variable of x. So we have to add the y, the x to it. So that means our dw, the x, is equals to 1 minus n. 1 minus 1 is 0. So we have y raised to power negative n, dy, dx. So we can now find our dy dx. So what is dy dx now from here? Anybody?
We divide.
Just write it out. Write it out from your book and let me know.
Okay.
So we have the y, the s to be equals to, when you divide both sides, it's like taking, let me just put it this way. When you divide both sides now, divide both sides by n by, let me just write it. Divide both sides by 1 minus n, 1, right? So we have dy dx to be equals to 1 minus n raised to power negative 1, y raised to power n. Do you agree?
Yes, sir.
W dx. So all we need to do, remember this is raised to power 1, negative. So by the time you find the reciprocal of these two, this is what happens. This is 1 raised to 1 over n over 1 over 1 minus n. So that's what we're doing. So now we can now substitute all these values into our equation 1. Then equation 1 becomes, substitute the y, the x into equation 1 now. So our equation 1 will now become what? The w, the x, in bracket 1 minus n raised to the power minus 1, yn plus p of x, y equals to f of x equals to f of x, y raised to power n. So we need to divide both sides by y raised to power n. Divide both sides by y raised to power n. So when you divide both sides by y raised to power n, this one we have the w, the x into 1 minus n. This one will cancel, plus now p of x, y. You know, when I divide by y raised to power n, it simply means n raised to, you know, when you have y raised to power negative n dot y, what does it mean? You agree with me? It's y raised to power 1 minus n. Do you agree?
Yes, sir.
y raised to the power 1 minus n equals to f of x. Which is not clear to from here, so that I can explain.
I don't understand. Sir.
Which one you don't understand? Please talk.
That the w dx is equal to like y. Stop it. Y raised to the power minus n dot y is equal to y.
Okay, you agree with me that when you have a raised to power n multiplied by a raised to power n, it's the same thing as a raised to power m plus n, right?
Yes. Sir.
The person that asked the question, did you agree that?
Yes, I do, sir.
So this is multiplication, this is multiplication.
Mm.
So it simply means I have 1 here. This is raised to power 1. If this is raised to power 1, then if I had negative, so it's just like y is the base, 1 plus negative n. It will give you y raised to power 1 minus n. Do you agree?
Yes,
I
do.
So it's the same. Then where do you get y raised to power n? It's like we have y raised to power 1 over n because we are dividing through, like this condition says. So definitely it's the same thing as y raised to power minus n. That's why it's come up. Okay, let's proceed. So the next thing is you discover that what is our W from up? Your W is equal to what?
Y raised to the power 1 minus n.
Then you allow, if I substitute W there now, you will not mind. You will agree with me. Yes or no? Somebody did not agree.
Yes, sir.
Okay, the W, the X will not be W the S 1 minus N plus P of X W equals to F of X. So how do I eliminate 1 minus W raised to power W? Multiply through by multiply through by 1 minus n. Now let me show you something. Remember, this is the Bernoulli equation. It simply means that we must have something in this nature. And as it stands now, the W, the X is carrying this. So we need to eliminate this one so that W, the S can stand alone, like the Y, the X up stand alone. So multiply through by this, you have it to be dW over the X. This one has cancelled this, plus 1 minus N P of X W plus 1, equals to 1 minus N F of X. So you can see that we have it in terms of linear equation now. So W is linear in this case, it's not complex. So it's linear. We need to solve for W and then substitute it. So how do I solve for W? Anybody? So you can solve for W so you can do that later. If you have time, do this W. You know the way you find your W from the previous method of solving the problems. And use integrating factor, use so many things to find your W. But let's look at the example. I just give us one example here, then we move on to another one. Example 1. This is just a proof, just to show, to justify that this representation works. So let's look at the examples. Example 1, dy dx minus y equals to exponential x y squared. So how do I know that this problem is Bernoulli problem? Who can tell us?
Because it has an extra factor.
What is extra there?
Why?
The y squared.
The y squared. Your y squared can be y cube, can be y anything. Remember, it's n, and n can be any value. So please take note of that. Don't be looking for y squared that day, or looking for any other thing. But always remember that the extra factor is involved in this case now. So let's look at it. Example. The solution of this will be, they can ask you to solve Bernoulli differential equation. They can say solve Bernoulli. Immediately they mention Bernoulli, they are talking about this method. So let W equals to, so what is W be equals to in this case now? Yes. Remember the first one says let W equals to y 1 minus n, right? But now we have this, our n is 2. What is W be equals to?
1 minus 2.
Really? 1 minus 2 is what?
Minus 1.
That's minus 1.
Yes, let W equals to y minus 1.
Minus 1.
Raised to power minus negative 1. So let's differentiate the W now. The W dx will be what? Differentiate this. Hello, differentiate it, please. Let's differentiate this. What do you have?
Minus y minus 2, raised to minus 2, dy dx.
Dy dx.
Yes.
So after we have this, the next thing we need to do is just to make our dy dx subject of formula. So if I want to make dy dx subject of formula, what do I need to do? All I need to do is just to say, divide both sides by what negative this and this. So I will have what? Negative y squared dw ds equals to dy ds. Any question? Any question? Substitute your dy ds in your equation 1.
So you divided both sides by what?
By this.
I think it should be 1 over instead of.
What is 1 over? I agree with you, but remember it's negative.
I got it. Yeah, the minus has gone. Yes, that's true.
The minus has gone. That's why we give it that way.
Yeah, I get it.
Do you understand now? The negative
Sir.
power, by the time you find the reciprocal of it, it will disappear. Can we proceed? Okay.
Yes, sir.
So let's call this one equation 2. Since we have equation 1 up, so let's substitute dy ds into equation 2. So dy ds we don't have it to be what? Negative y squared dw dx minus y equals to exponential x y squared. So we need the w, the x to be alone. What do we need to do?
Divide also by minus y squared.
Divide both sides by minus y squared. So we have the w, the s, plus so what will be the answer for this? Y raised to power what?
-1.
Anybody? Remember when you have y over y squared, is it not this? Right?
-1.
1 all over y, which is the same thing, y raised to power -1. So it's going to be y raised to power -1 equals to e raised to power what? Negative e raised to power s. It's going to carry negative because you are dividing through by negative y. Yes. So in this case now, we can call this one equation 3, which is linear. Okay, let's just go a further. We know what is our w. Our w is what? Please talk.
W is y raised to -1.
So we have w equals to exponential minus exponential x, negative here. So we call this one equation 3. Then, now that we have equation 3, who can tell us what to do here? That's the question I was asking you to do the other time when I stopped for the proving that I was trying to verify. So what you need to do here is to use integrating, just say using integrating factor. Integrating factor. We know integrating factor formula to be what? Who can remind us?
E raised to power exponential p dx and p
Rho equals to e exponential integral of what?
ps dx.
dx.
That's all. We know our p. What is p of x in equation 3?
1.
Really? Who else?
It's 1.
Y raised to -1.
What's the answer? Our p of x from equation 3 is what? Anybody? Do we all agree is 1?
Minus exponential.
-1.
-1. Okay, I can see another one. Who else again?
-1.
-1. Okay. Who else? So you said -1. Where is -1 there? How do you get come across your
Minus e
-1?
raised to power s.
+1 actually. That's why it's not +1.
Because of what, please? Ibrahim, how do you get your
Minus
own
e
one?
raised to power x.
Is ordinary one.
It's ordinary one. How do you get it?
It's ordinary one.
The answer is 1. Remember, p of s is coefficient of everything here. And the coefficient here is what? 1. Remember, we are working with W. You must learn how to take your grant. When I say really, you see Ibrahim just keep quiet. Watching what you guys will see. And some of us give us alternative, which is not the same. So let's check. Exponential. Now, when you have 1, the x is the same thing as exponential integral of the x. When you integrate this one, what do you have? Exponential x. That is what you have. Then, if you have exponential x, now I'll do something now which I want you to be careful with. So all we need to do is just to multiply both sides with exponential s. And don't forget, exponential x w prime equals to negative exponential 2s. Do you agree with me? Hello?
So, from where, sir?
From where I stop now, do you agree? Now, it's more or less that you are doing a kind of product rule that when, remember our topic, when you finish, immediately you finish your, let me go back a bit, if I can locate some of those questions. Okay. When you finish your integrating factor, what do you do with integrating factor? You use it to multiply. Am I right? Please
Yes,
go
sir.
to your book. Don't let me go back because it will be difficult for me to find some of those stuff. It will be, so for us at this point, when you multiply, when you use it to you use this particular integrating factor to multiply both sides, to multiply through, in order to, we are looking for W, don't forget. So when you multiply it, what will happen? Remember is this, I'm just using this, this is the W dx. So you agree with me? Hello?
Hello, sir. I was
So,
thinking that you're going to apply the formula that we are used to, where W will be 1 over the integrating factor. Then when you open a bracket, then
the
we
W
have
will be what? Let me write it down for you.
W will be 1 over e raised to power x. Then open a bracket. Then we have P of x dot Q of s dx. Sorry, I mean
of x.
No, sorry. E raised to power x dot Q of s dx. And the Q of s in this case is e raised to power. The Q of s in this case is negative e raised to power.
No, we've not solved that one. We are still going there. That's what we are. That's where we are going to.
Okay, sir.
Do you agree with this? Did you understand the way I come across this?
No, sir.
That is the question I'm asking you guys. Now, multiply, take your this back to this place to multiply through. So what we do is a kind of product rule we normally do when it comes to this type. You agree with me that this is just like how will I explain so that you can get it right? You know that prime means differential equation.
Yes, sir.
Do you agree?
Yes, sir.
Yes, sir.
Okay, good. If that is agreement, that you remember the Q of x that you are talking about. What is Q of x in this case?
Negative e raised to power minus x.
Minus negative. That is what I'm saying. That is the other side. So just follow me. When you get to that point, you will get to know what I'm trying to do. So at this point now that I have the prime here, I will now integrate. I've already used it to multiply. You know, when you use e to multiply e raised to power s here, it returns to this. So integrate both sides. When you integrate the both sides, what do you have? where you have integral of exponential of this side, the x, equals to integral of exponential 2s dx. So this one we cancel this. So we have ES W equals to, let's integrate this one. I have 1 minus 1 all over 2 exponential 2x plus c. So by the time we look for W, don't forget, we can divide both sides by exponential, right? So if you divide both sides by exponential, you have W equals to negative 1 over 2 E what will happen to E? Anybody? What will happen?
I think from what I can see here, you now divide both sides by e raised to the power x.
Exactly. But before we divide both sides by e raised to power s, let me just write this one. Let's say E. Remember here, what is W from onset? Please go back to your notes. From number 1, when we are explaining this question, we said let W equals to what?
W is y raised to minus 1.
Y raised to power
minus 1.
Yes, EX y raised to power minus 1 equals to 1 all over minus 1 over 2 exponential 2x plus c. Now, we can divide both sides by saying negative y equals to negative 1 over 2. When I divide both sides, this one will remain with minus 1, right? Plus exponential negative this. You remember what I did? Because this one we have e raised to power 2s over e raised to power s. 1s is the same thing as e raised to power 2x minus x, which is the same thing as e raised to power x. That is what happened here. But you don't need to write all those things. So at the end of the day, that's not the final answer. Our final answer must be in y. So if I said y equals to this, well, how do I write it down? Y equals to what? That's the final answer. Any question? Does it come back to what you knew before?
Yeah, it looks like it. Maybe when I resolve it, I will find out.
Just resolve it. What you need to do is just, at this point, just take the product, a kind of product rule, and put it here, then integrate it in order to cancel the differential equation and get your answer done. So anytime you see extra factor in any question, this is the way you do it in Bernoulli way. But let's quickly look at the Riccati. Riccati has a lot, and Riccati differential equation. So we have a lot. We have the y, the x is equals to look at this form, a of x y squared plus b of x y plus c of x. It's the first order ordinary differential equation in a quadratic way. So you have to be careful. This is in a quadratic way. The first one is in n. This is always in quadratic way. And look at the form. Call this one equation 1. We do substitution too in Riccati. Said let y equals to y1 plus 1 over v. Excuse me. y1 plus y all over v. And your v is the same thing as v of x. That is, they are dependent, they are quadratic independent variable. Then our y1 is a particular solution. So, but let's look at this. Call this one equation 2. Let's differentiate our equation 2. The y, the x. How do we differentiate the y, the x? In this case, the y, the x equals to dy1 over the x minus how do you differentiate? Don't forget, the v is also in terms of x. It will not be the v dx. But how do you differentiate v? Remember, v is the same thing as v raised to power minus 1. Differentiate it. How do you, what do you have?
Minus of v raised to power minus 2.
Yeah, that's what I put here. You can see. So it's going to be v raised to power 2. Then we can now substitute, solve this problem. The y dx equals to the y1 the x minus 1 over v dv dx. So we will now begin to compare and contrast the two together. Now we have this. We can write this one, a of x y squared plus b of x y plus c of x equals a of x y1 squared plus b of x y, everything you see y, you turn to y1 plus c of x plus c of s. Then what lasts there? Anything? Who can tell us? Hello? Minus 1 all over v squared dv dx. dv dx. Remember, what I did was, the question says the equation 1 says what? This is what I did. I just substituted this now. Look at it. This is my transformation, right? This is differentiation now. I now said dy dx is equals to this. Everything here is my dy dx, which we are given, minus everything we are not given. Are you getting it, please?
Yes, sir.
Yes, sir.
Let me explain to you. Remember, dy dx is equation 1. So I have dy dx here in this side. Look at this equation 3 now. The left-hand side is dy dx, which I put here. The right-hand side is dy1 dx, which I also did here to this point, minus everything remaining. Minus 1 over v squared dv dx. Are you okay with that now? Can we proceed? I'm waiting for you guys.
Yes, sir.
Yes, sir.
Okay, if that is the case, let's look at this. A, what is A? What is y squared? Somebody should tell us if you want us to proceed from here. What is y? Go to your notes. I declare y.
Y1 plus 1 over V.
Is what? I can't hear you very well.
Y1 plus 1 over V.
Thank you. Y1 plus 1 over V. So you substitute it. Squared. Plus B. What is B is what? Y1 plus 1 all over V again. Plus C. Equals to, remember the other side is already Y1, Y1. Just put them there. A, don't need to put of X again at this point. A Y1 squared plus B Y1 plus C minus 1 all over V squared dV ds. So can someone tell us, we need to open the bracket now. How do you open this one? What is the value for this? Somebody should do it. That is y1 plus 1 over 2v multiplied by y1 plus 1 over v. So open it and tell us the answer. Our time is fast spent. What do you have? Y times this, y1 squared.
Y1 squared plus 2y over V plus 1 over V squared.
2y1
2y1
over V.
over V plus 1 over V
Yes.
squared.
Plus 1
Over V squared.
over V squared. Thank you. So we'll be using this one now. So let's put it there. So we have A in brackets y squared 1 plus 2y1 over V plus 1 over V squared. Plus B into y1 plus 1 over V plus C equals to A squared 1 plus B y1 plus C minus what? 1 over V squared dV dx. So let's open the bracket with A first and see what we have. When you open the bracket, you have AY squared 1 plus 2A y1 over V plus A over V squared plus by1 plus B over V plus C. Let me just put equals on that so that we can see the one that cuts. Equals to A y1 squared plus B y1 plus C minus 1 all over V squared dV ds. So which one cancel each other?
AY square.
This one go with this. Which one again? B1 and this go with this. C also go with this. What's remaining? So we have it to be we have the remaining parts to be what? Sorry, we have the remaining parts to be, let's go, 2a y1 over v plus a over v squared
Plus B over V.
plus bv equals to minus 1 over v squared dv ds. Do we agree with me? So
Yes, sir.
we multiply
That's B over B now.
where? B over
The other
V
side.
or BV?
No, it's B over V.
It's B over V.
Okay, sorry. B over V. I'm already solving it. Multiply through by V squared. When you multiply through by V squared, what happened? Here we have what? 2a V y1. Remember, V squared will be cancelled. This is to remain 1V. Plus A plus BV equals to minus dV dx. So if you take minus dV dx to the other side and bring out the constant, what do we have? We will have dV dx plus 2AV y1, or let me just put it this way, 2AY1 V plus BV equals to negative A, because A does not contain V. So we can go ahead and make cases now. dV dx will be plus 2A y1 plus B in V equals to negative A. So in this case now, how do we resolve this matter? Haven't you have the mindset of what happened during our integrating factor of 18? How do you get our V out? Anybody? So from here, you can use integrating factor again. So when you use integrating factor, it is easier for you to solve it. For example, say dV dx, call this one P of x, V equals to Q of x. You remember, they are all constants. I'm just using it. Using integrating factor. Integrating factor, you have it to be rho equals to exponential integral of P of x dx. So remember, this is not a solution. This is not a solution. I'm just explaining the way the formula works until when we get to the final solution now. So when you multiply this one, the way I was explaining to you the other time, P of x dx dV dx plus P of x integral of P of x dx equals to Q of x multiplied by integral of P of x dx. So in this case now, this particular scenario, this particular one, will be at the same time as differential of x, v, because by the time you take everything up and down and you integrate the v dx, you have v. So that's why we normally say v exponential integral. The way I did the other example up, the x equals to q of x exponential p of x dx. So it's the same thing. So I can go ahead and look for my v now, because I can make v subject of formula from there, because I will have done the integration, do everything I need to do. In the real life, I can just say v is equals to what? Let's say integral of, because you have to integrate the both side. In this case, integral of q of x exponential integral of p of x dx, everything divided by the remaining one here. But let's solve the example. That is the step. I'm just giving us the procedure. So, but let's look at the example, how it works. Example 1. Example 1 says, solve y
Come again. You
prime.
say v equal to what, please?
Look at this.
Hello, sir.
You remember you have to integrate both sides.
Yes.
In order to cancel the differential equation here. Yes, somebody's talking.
Yes.
Did you understand what I'm doing?
No, I was just like looking at how you got that v equal to integral q of x exponential.
Okay. Remember, this is differential equation, right?
Yes.
With respect to x. Now, if this is differential equation, for me to eliminate differential equation here, what do I need? You integrate. When you now integrate, that's where I will have access to my v, to be able to make my v subject of formula. So if I integrate both sides now, let's say I integrate this side, this is what happens. Integrate both sides. The d, this particular d, differential equation will cancel. I will left with v and the integrating factor. So which is here. And since I am making this one subject of formula, I will divide both sides by exponential integral of p of x dx, which I did. Remember, I don't know this value until I have a real question. That's why we are going to the example now.
Okay.
Am I communicating now?
Yes.
Okay, let's look at the example. Then you can ask more questions. Solve y prime plus 2xy equals to 1 plus s squared plus y squared. Remember I told you, the question I gave you initially, I said -1, negative x squared plus y squared using Riccati equation. So you can use this method to solve it. But let's look at this. So they asked us to solve this one to equals to this. Now, where y1 is equals to x is a solution. They put it there. So from here now I have the y, the x. That's what I have. The y, the x plus 2xy equals to 1 plus x squared plus y squared. So x squared plus y squared. How do I solve this? Make the y, the s subject of formula is going to be, remember, take this one to the other side. Just take this one to the other side. Make this one alone here. You have, I can write it this way by saying y squared minus 2xy plus x squared plus 1, depends on you. Call this one equation 1 or equation triangle. So from our original equation, what is a of x in this case? What is b of x? Then what is c of x? Somebody should tell me. Look at your equation very well. I'm waiting for you guys.
A of x is 1.
A of x is what? Hello? 1. B of x?
2.
No.
Wow.
And c of x
2
is
now,
what?
minus. That's
Minus
minus
2,
2.
minus 2x. Minus 2x.
C of x is what? Okay, let's continue. Let's y equals to s plus 1 over v. S plus 1 over v. When you differentiate your x and differentiate your y, what do you have? What do you have when you differentiate it? Anybody? You have the y, the x is equals to, when you differentiate x, you have 1 minus 1 all over v squared dv dx. So we can now equate, let's call this one 2, or start equation triangle. Equate equation.
We already have equation triangle. Actually, maybe you could call it maybe equation triangle 1.
That's why I said triangle, making 2 triangle.
Okay.
You understand? Equate equation triangle and triangle together. So how do we do that? Remember, we have equation triangle to be y squared minus 2xy plus s squared plus 1 equals to 1 minus 1 v squared dv dx. So in this case, I can substitute my y into this equation. I know my y. You and I know my y. So we can substitute y. Our y is what? Our y is what? X plus 1 over v squared minus 2s into s plus 1 over v plus s squared plus 1 equals to 1 minus 1 over v squared dv dx. So how do we expand this one? The same way we did the other time. What's the value?
X squared plus 2x over v.
S squared plus
2x
over v
plus 1 over
plus
v.
1 over v squared minus 2x squared minus 2s over v plus s squared plus 1 equals to 1 minus 1 all over v squared dv ds. Do we agree? So something cancel now. We have s squared is here and s squared is here. Go with this. Do you agree?
Yes.
So we have this go with this. Then 1 also go with 1. Do we agree? So it remain 1 all over v squared equals to negative 1 over v squared dv ds. Multiply through by v squared. Yes,
I have a question.
go ahead.
We have square. We'll go in minus 2. We have 2x squared here now.
Yes, now we have 1s squared here, another s squared here. When you add it together, it's 2s squared. And you have negative 2s squared. Do you agree now?
Yes, sir. Thank you, sir.
Okay. So when you multiply through by v squared, you have
Hello, sir.
1 equals to
Hello, sir.
negative dv dx.
Yes.
So in this case, what we have, we cross multiply the s equals to negative dv. When you integrate the both sides, you have x equals to negative v plus c. So we can now make c, make v now. Our v will be what? Negative s plus c. Do you agree? Let's go to our y again and substitute our v into it. Our y is now said, therefore, y equals to x plus 1 all over minus s plus c. That is your final answer. Or you can rewrite it in another way. Or we can rewrite it, or you can rewrite it, take this one up. You can do it this way. Y equals to x plus minus s plus c raised to power negative 1. So any question we have on this aspect, we can solve it using the same method. But let's try and look at another method, another one before. Who can tell us the method we use here at this point? Hello? Do you still remember separable differential equation?
Yes, sir.
Okay, that is what we did there. Any question? Okay, let's look at this. Solve y prime plus y2 equals to 1 plus x squared. And where y1 equals to x is a solution. So in this case now, our dy our dy ds is equals to negative y squared plus 1 plus s squared. So what is a of x in this case?
Minus
Who
1.
can tell us a of x?
Minus 1.
Negative 1. B of x? C of x? Do you agree?
Sir, I think I have a question.
Go ahead.
Okay, so like this equation, now, B of x is not present.
Yes. Look at it.
Okay.
B of x is not present because if you look at this form now, B of x is supposed to be a linear, but it's not there. So instead of B of x now, we jump to x squared. And x squared cannot be. Are you getting it? They are part of
Yes.
C. So that is why you have to be careful. Look at the way we solved the first one. That we said our B of x is what? That is, B of x must contain y. Do you see anything contain y here? Are you getting it?
Yes, sir.
Okay. Is that your question? Have I answered it?
Yes, sir. Yes, sir. Thank you, sir.
So let's y equals to s plus 1 over v. And the y, the s, is equals to what? 1 minus 1 over v squared dx dv ds. So we can substitute it in this place. I say minus y squared plus s squared plus 1 equals to 1 minus 1 all over v squared dv ds. So can we substitute this one? We have x plus 1 all over v squared plus 1 all over v, sorry, all squared plus s squared plus 1 equals to 1 minus 1 all over v squared dv ds. So what do we have here? The way we did the other time? Somebody should call it for me. Is in your notes.
Minus x squared. That's x squared plus
S squared plus
2x over v
2s over v
plus 1 over v squared
plus 1 over v squared plus s squared plus 1 equals to 1 minus 1 all over v squared dv dx. Remember, they did not find the square, they did not find the square with negative. This negative is stand alone. That's why we can get minus 1 for our a. So please take note of that. So you can now use the negative to open the bracket now. You have minus s squared minus 2x over v minus 1 all over v squared plus s squared plus 1 equals to 1 minus 1 all over v squared dv ds. So this This go with this. One go with this one. So we are left with negative 2x over v minus 1 all over v squared equals to minus 1 all over v squared dv dx. So how do we solve this one? Multiply through by negative v squared. Multiply through by negative v squared, because we need to eliminate this whole thing. So when you multiply through by negative v squared, so you have 2xv plus 1 equals to dv dx. So we need to take this one to dv dx. So if you are taking it to dv dx, what do we need? We need dv dx minus 2xv equals to 1. Then, who can tell us what to use at this point? Hello?
Integrating factor.
Okay, thank you. So what is integrating factor in this case? What is x? What are we using as p of x?
2x. That's 2x.
Okay, so we have our rule to be exponential integral of p of x dx, which is same thing as the p of x is equals to negative 2x. Don't forget that negative. So we have exponential integral of negative 2x dx. So when you integrate this, what do you have? Remember, you have to integrate. You have s squared over 2. So that's our integrating factor. So by the time you match, we now go back to the equation. The same thing, the same method I've been explaining to you guys, we're going to use minus 2. So when you use a kind of using a product rule, at the end of the day, you have d of x that I was trying to do the other time. This is differential equation with respect to x, merging with exponential of this v equals to exponential minus x squared. So at the end of the day, what you need to do is integrate both sides. So when you integrate both sides, this particular one will disappear, but let me just write it. The x exponential minus x squared v, integrate both sides, the x. So this is exponential minus x squared v equals to, when you integrate the other side, what do you have? Who can tell us? What do you have when you integrate this side? Are we still there? Pascal, what do you have?
I think we are still having the exponential minus x.
Yes. What are you going to have? You can't remember. Okay. That's
It's something that
interesting.
exponential minus x, no?
Really? It's not possible.
Okay, sorry.
So,
That should be lane. That should be lane x.
don't worry. You don't need to. You don't need, see. Go to your notes. All of you, go to your notes. Go to your calculus note. How do you integrate exponential minus x squared? Go and get it. I will just help you write it the way it's supposed. I'm not going to integrate it for you. The x. So we divide both sides by this. So we have v equals to integral of exponential minus x, the s over exponential. So go and check it. This is plus c. Where you integrate it, don't forget plus c. So that will be your final answer for this. If you don't find it and you are lucky, you are given the same question, I wonder how you will solve it. We'll be solving this for a long time. Guys, you need to buckle up, please. Remember, you are writing an exam. And we can't afford to be doing all this. I think for the Clarius differential equation, you can read it off. It's simple and direct from your book. Or you still want me to talk about it? I'll just give you the general name for Clarius so that you will see the way it looked like in case you are given the question. See the difference between them, differential equation. So when you say y equals to xy prime plus fy prime. So the solution is a family name, family line. It's family lines. Y equals to cx plus f of x. So also may process a singular solution in the sense that also may process a singular solution, that is s equals to f prime of t, then our y equals to f of t minus t of f prime of t, where your f prime of t is not equals to 0. Please take notes. Well, how do we show this? On a literary way, it's very simple. How do we prove this? You can just prove we have, let's say y prime is equals to c. Then y prime if y prime equals to c, based on what we have up, we can say y is equals to what? Based on what you have. Can somebody tell us? If y prime is equals to c, if I substitute c there, look at the family name. Y prime equals to c. So we have y equals to sy prime plus f of y prime from the family name. So it simply means that what we have is the same thing as SC plus f of c, which is the same thing as y. But that's not the major issue. The major issue is, let's look at the example. When you have y equals to, I've seen this question before, right? Plus 1 all over 2 of y prime raised to power 2. So we need to identify our f of y prime. Our f of y prime is equals to 1 all over 2 y prime raised to power 2. That is our f of y prime. Then, from the particular solution that we have here, our f of t will be what? Is 1 all over 2 t squared. Then I can say if f prime of t is equals to what? 1 all over 2 in bracket 2t. This cancel this. That is, our f prime of t is equals to t. So if f prime of t is equals to t, we have then f prime prime of t is equals to what? Is equals to 1. Remember, the law says f prime prime of t is not equals to 0 based on the rules here, based on this singular solution. So by the time you differentiate it, you get to whatever you are given to solve. Then what it's trying to tell us is a kind of general solution whereby it works for, we have the singular solution, whereby our singular solution in this case is a form of t, and second derivative always should prove that second derivative is not equals to 0. Once you can establish this, then you can conclude. So on that time, you will be able to have access to different questions and different. So it simply means it works for every angle that we are working on. So if you look at this one now, if you look at this problem now, it's always the solution is always work for them. So if you are given this, if they are given y equals to c of x plus 1 all over 2 c squared, we have a singular solution from there, and you said s is equals to minus f prime of t, which is same thing as negative t. Then what is happened to y? Y is f of t minus t, f prime of t equals to what? Negative 1 all over 2 t squared. So it simply means that y equals to 1 all over negative 1 all over 2 of negative x all squared. It will work. It also work for any other thing because it's a form of y equals to 1 over 2 x squared. It also works for any graph because remember it's a family line where you have different graph that come different angle. All this form of, when you sketch it, you have something similar like this. Let me stop sharing. So guys, any question?
Too much information actually. I will have to digest.
I believe please guys, mute yourself so that we can hear ourselves very well. Yes, that is why, it's a facilitation. I'm just trying to make it